Hi there. For this video, we'll be having an introduction about the first conic section, circles. So to start, circles are defined as the set of all points equidistant from a fixed point. As we know, its figure is given by this. Take note that when we say equidistant, we're talking about the distance here, which is the radius, which is this one. So this is the distance that we are talking about in this definition out here. Moreover, when we say fixed point, we refer to the center of the circle, which is given by this one. Center let's denote it with this point C, with coordinates h and k. So the idea here is that these points out here, so doesn't look like points, but since it is connected, it formed a line. These points out here are all of same distance from this center point. This out here is r, this out here is r, this out here is r, and so on. So that is the idea behind circles. So take note of this definition, since usually when we talk about circles, we simply think about this. But in the study of conic section, this is the main idea in studying circles. Aside from this, we have an equation for it. So to obtain this equation, we first choose an arbitrary point, say xy, this one, and we recall the distance formula between 2 points, which is given by this. So in here we have z is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, wherein the first point is given by x1, y1, and the second point is given by x sub 2, y sub 2. So let's try to apply this distance formula with our given. So let's try to denote this by x sub 2, y sub 2, this by x sub 1, y sub 1, and our distance is given by this radius. So plugging in these values out here will obtain this one. Then from here we can get the squares, both sides, to remove the square root part out here to obtain r squared equals x minus h squared plus y minus k squared. Now lastly, we just interchange these two to obtain this. This out here is our equation for the circle. So this is the usual equation that we'll see in circles. Now some remarks. Take note that the form earlier is actually called the center radius form, since we can easily obtain the center out here as well as the radius out here. So upon having this form, we immediately know what the center of the circle is as well as its radius. Aside from this, take note that if we set the center to be equal to the point 0, 0, or the origin, and the radius to be 1, so let's try to plug in these to the center radius form. So we'll have x minus 0 squared plus y minus 0 squared, which is equal to 1. Simplifying, and we'll obtain x squared plus y squared equals 1. This out here is what we call the unit circle. So this is something important again, since usually in problems, it's just stated that we have a unit circle. So when we see that one, immediately, this is what we are referring to. Lastly, take note that the H out here refers to the translation of the circle from right to left, or it's like moving a unit circle to the right then to the left. The K out here represents the translation of a circle up and down, so it's like moving the unit circle up then moving it down by changing or manipulating its value. And lastly, the radius out here, the radius out here refers to the change in size or the scaling of our circle, our unit circle. So to understand this better, let's have a graph and let's plot the unit circle out here. So let's first change the radius out here. So if we change the radius and increase it, so we'll have this. So this one, take note that 4 here is equal to 2 squared. So the radius here is 2. So clearly out here, this is 2 units. So as you can see, by increasing the radius, we were able to magnify this unit circle out here. So that is the idea upon changing the value of r. If you want to make the circle smaller, you can decrease the value of r. Now let's try to check what happens when we change h out here. So we'll have this one. So as you can see, so take note that in here, the value of h changed to 5. So what we did is we translated the circle 5 units to the right. So indeed, if we check, so if this is the center of the circle, we move it 1, 2, 3, 4, and 5 out here. So that is the idea behind this h value out here. It's like moving the circle to the right or to the left. Now lastly, let's try to inspect what happens when we manipulate k. So we'll have this. So in here, observe that the value of k is equal to 1. So the idea here is that we move the unit circle 1 unit up. And indeed, if we check out here, it was moved in here, the center from this to this. Or like this circle moved 1 unit upward to this. So that is the idea behind these values. Now that we know the basics on circles, let's try out some examples. So in here, we are tasked to find the equation of circle given the center and radius. So before we start, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So to solve this one, first take note that the equation of the circle we're talking about in here is the center radius form that we obtained earlier. So just to recall, this form is given by x minus h squared plus y minus k squared equals r squared, wherein hk refers to the center and r refers to the radius. So let's try to apply this one into what we have. So starting with this, since we are given the center which is this one. So we have h and k, and we are already given the r. We simply plug this one into our formula, or this form out here. So we'll have here x minus 1 squared plus y minus 2 squared equals 3 squared. Or, upon simplifying, 3 squared is equal to 9. And this is our equation of the circle for the first item. So it's as simple as that. Next, let's try this second example. Again, we are given the center and the radius. So we have this to be h, and this to be k, and this is already r. So we'll have here x minus negative 1 squared plus y minus negative 3 squared equals 2 squared of 2 squared. Take note that in here, this simplifies to x plus 1, and this simplifies to y plus 3. Moreover, 2 squared of 2 squared, let's put out here. In here, take note that what happens here is that we'll have 2 squared times square root of 2 squared, and 2 squared is equal to 4, and square root of 2 squared, so just cancel, and we'll have 2. So this is just equal to 8. So given these, we conclude that the equation of the circle for this one is given by x plus 1 squared plus y plus 3 squared equals 8. This out here is our final answer. There. Now let's go on to our final example. In here, we are given again the center and the radius, so we plug it into this one. So we'll have here x minus 0 squared plus y minus 0 squared equals 0 squared. So when simplified, this is equal to x squared plus y squared equals 0. And what does this mean? We'll take note that since the right side of the equation is 0 and we have squares out here, so we know that this is non-negative, they can never be negative, then the only possible case out here is x equals y equals 0. So what does this mean? This means that we just have a point. We just have a point. So this means that this out here is not a circle, but rather a point. So that is the answer for the last one. So take note of that one, that whenever we have the radius to be 0, then we can't have a circle with that, since imagine if this is the graph and this is the point, then there is no distance, then it's just a point, just the center. So yeah, take note of that one and that, and these are our examples for the first one. So I hope you got these items correctly. Let's now move to the next example. In here, we are tasked to determine the center and radius given the equations out here. So again, feel free to pause the video so that you may try this one first on your own. Okay, so let's start. So again, to answer this problem, we take note that the center radius form that we learned earlier is given by x minus h squared plus y minus k squared equals r squared, wherein the center is given by hk out here and the radius out here is given by the r on the right side of the equation. So let's try to apply this in our examples. In here, take note that this one is already in the center radius form, so it's easy to get the center and the radius. So take note that this one out here, since this one is x minus h and y minus k, so we'll have here h, this would be the k, this out here would be the r. So given this, we conclude that the center is given by the point 2, 5. For the radius, we just get the square root of this one. So we'll have here the square root of 49, that is equal to 7. So we have the radius to be 7, or 7 units if you like to put it. So that is the answer for the first one. Let's move on to the next sub-item. In here, take note that we still need to manipulate this form to make it in center radius form. So that is, take note that we can write this as x minus negative 3 squared plus y minus 0 squared equals 8. Take note that, now let's do that later. So we'll have here 8. And so in here, we can easily see now that the center is given by these points out here. So we have center to be the point negative 3 and 0. For the radius, let's get the square root of this one. So we have square root of 8. Take note that square root of 8 is equal to square root of 4 times 2 inside. So this is equal to 2 square root of 2. And so this is already in the simplest form possible. So we conclude that the radius is given by 2 square root of 2. And again, if you want units. So you got that one right. And let's move on to the last sub-item. In here, take note that we have a coefficient here of 2 and a factor of 2 out here. But in our form, we don't have any of that. Since these two are the same, what we can do is we can divide both sides of the equation by 2 out here. So that would give us x squared plus y minus 7 squared equals 72 divided by 2 is 36. Moreover, take note that we can write x squared out here as x minus 0 squared plus y minus 7 squared equals 36. And so, clearly, we can now see the center, which is given by this. So we have center to be the point 0 and 7. For the radius, we just get the square root of this one. So we have square root of 36, and we know that to be 6. So we have the radius to be 6 units. And so these are our final answers for each item on this exam. So I hope you got that one correctly. And to formally end this, here's an exercise that you can try to work on. So in here, we are tasked to find the center and radius of the circle defined by this form out here. So you might be wondering, since this one out here isn't in the center radius form. Rather, this one is actually in its standard form. So you can check the previous video since I mentioned about something about the standard form. And actually, this exercise item is a preview to the next video, since in the next video, we'll be talking about how we can convert a standard form to a center radius form. So that is a hint for now. Take note that you can manipulate this form and make it in center radius form to immediately see and find the center and the radius of the circle. So that's it. I hope you learned and enjoyed this video. Feel free to comment down below any suggestions, recommendations, and if you have a solution and answer for this exercise. So yeah, that's it, and that's all for this video.